Ham TV on the ISS is a very old story. First, just a few questions actually for you. Who has seen this International Space Station, gone out in the garden and seen it going over at night? So, fantastic. So you all know about orbits and it coming over the horizon and only being there for about 9 minutes. So contacts with the ISS from the ground are inevitably fairly short because it's moving very fast and it's in a fairly low Earth orbit. Contacts with the space station, amateur radio contacts with the space station and its precursor Mir and other objects goes back almost to the beginning of manned space flight. It's been done for 20 or 30 or 40 years. On the space station, though, it is now a fairly regular event with schools contacts where schools develop a whole load of questions, normally about 20 questions. That gives you sort of 30 seconds, or gives the astronaut about 20 seconds to answer each question. A kid from school is put in front of a microphone and asks his question, which the astronaut's actually already heard the question because he's had a list. I think they were telexed up originally, but they're probably emailed up now. So he knows how to answer the question, and then there's 20 questions. So that's school contacts, ARIS contacts. You may have heard of, and there's one a week, or quite often 2 or 3 a week. It depends which astronauts are up there and how keen they are. But there's a lot of it going on. Now that's all very good. It's very attractive to schools. Kids love space. Space is still sexy somehow. And for a 10-year-old or a 15-year-old to be able to say, "Oh, I have spoken to an astronaut, and he's answered my question," is pretty good. But it's missing the picture side. And for years we've thought it would be a really good idea to have a video link, a television link, at least a downlink, as well as the sound link. The sound QSOs, the voice QSOs are done on 2 meters up and down. So that was an idea that sort of festered. It's not the right word, but it's an idea that's been around for a long while anyway. Two things that make it quite difficult. One is the basic link budget and the power and all that sort of side, the RF link budget. And 2 is what band to use, because originally when we were having this idea, there were no S-band or L-band or whatever antennas on the space station, so the only option, the highest frequency antenna, was 77s, and the thought of trying to transmit FM, as it was then, FM TV down from the space station on the 77s didn't really appeal. We thought there might be a few people who thought that was not a very good use of 10 megs of band. Anyway, and there's other legal limits that the satellite band, the amateur satellite service, has only got 3 megs of spectrum anyway, so long and complicated story, but it wasn't really practical. So again, quite a long while ago, the idea of using digital TV came up, and then at around that time, the Europeans launched what's called the Columbus module. You may remember it being launched. I think it's been up there for 6 or 7 years now, but it was again gestated over many years, and there was some funding acquired that enabled us to put some patch antennas on the Columbus module. They were built in Poland by a Polish university, Wrocław University, and they were developed by them, and they're patches that are just on the outside. I'll show you some photographs later. It was touch and go as to whether they get on. The Columbus module had been sitting in Cape Kennedy for, I think, almost years finished, but we hadn't got the antennas on in time. And the antennas were only fitted onto Columbus about a week and a half before the whole Columbus module was taken out and stuck onto the shuttle. So it was very knife edge in terms of time and scheduling. One of the difficulties as a result of that is that testing of these antennas in situ was very limited. So when we come on to talk about link budgets, we sort of know what the gain of the antenna is. It's a patch antenna. Some debate as to whether it's 6 or 3 dBi, C, whatever, but it's something like that. What we probably don't know with any accuracy is the loss in the coax between the antenna and the socket inside the Columbus module. So there's a whole load of sort of uncertainties. Anyway, I'm rushing ahead of the story really, but I think it really first started with a proposal that we made to the ARIS team, the ARIS Amateur Radio on International Space Station international meeting that was held in Surrey. I got Dave Mann along as our certainly then a very digital TV expert who could talk with knowledge and impress the people. And everybody thought it was a very good idea, but how do we get a box transmitting digital TV up there? So again, it festered for some years. So that's the background, and it's gone on for a long while. Then suddenly, I know we're streaming this, so I'll be careful with my words. Do any of you work in organisations where they get to the end of the financial year and there's some money left in the pot, and if you don't spend it by the 1st of April, you won't get it next year again? Yeah? Okay. I suspect, this is only my suspicion, maybe no truth in this, but I suspect that a part of ESA found they got some money in the pot on about the 1st of March and were desperate to spend it before the 1st of April. And suddenly somebody came up, like actually AMSAT Italy came up and said, well, we could build a DATV transmitter for the space station. Why don't we? And that's where the fundings come from. The one downside, of course, is what we were actually trying to cogitate or design was an amateur television repeater. What we really want, and still really want, because the antennas are dual band, L-band, L and S, is to have an L-band uplink and an S-band downlink. So when the astronauts aren't using it for schools contacts, they could just push the big blue button, or whatever colour we made it, and link the receiver to the transmitter. We haven't quite got there yet, although it's still in the works. What is currently up there, I'll describe it in more detail in a minute, is the S-band transmitter. That's there, and waiting to be tested. And we're now designing and getting sort of permission to build the L-band receiver. That is still work in progress. So anyway, this talk is really about the DATV HAM TV project. I think I've talked about the original sort of analog standard idea. How could we do it with analog, or is digital the only way to do it? There were a number of link budgets calculated that showed with something like 10 watts of power and 90 centimetre dish on the Earth, the analog the link margin was rubbish, so that didn't work very well. In comparison, similar power levels, similar antenna gains and whatever, a data rate of about 1 megabit. Not sure of the range that's. 1,000 kilometre range, so that's not actually out to the horizon, that's about when it's about 10 degrees above the horizon. So that would give you 6 or 7 minutes. And there's a link margin there that's green, so 6.9 dB link margin? Just. Yeah, just. Okay. It's just green, and it's actually only got an antenna diameter there of 90 centimetres. So the current sort of baseline spec, although again, because we're not sure of the loss on board, this coax loss, we're saying a 1 or 1.2 metre dish is probably the ideal one to be using. You can just make out, if I can find the pointer, you can just make out maybe the antennas there. There are not very many photographs taken of these antennas. There's two, 1 and 2. They're obviously on the nadir pointing part of the International Space Station, the bit facing the Earth, and not many things go there and hang out there and take photographs. They were white, quite sort of bit of science interest. When they were launched, they were white. They are a plastic sort of foam structure. They're now, obviously, that's that pretty goldy colour. We believe that's due to erosion by atomic oxygen particles in space. So it's not full of nothing, there is stuff up there. It's quite low, the space station's only at about 400 kilometres, so there is quite a bit of stuff up there. Ringed it. Okay, the ham transmitter, as it was built, it's been built by an Italian firm called Kaiser Italy. They were in contract directly with ESA but with AMSAT Italy giving them advice and guidance and kicking them, as you'll see, it's largely SR Systems encoder, etc., and a Kuhn PA 20-watt S-band PA. So it's some fairly heavy, well, hopefully heavy-duty commercial bits of hardware. Power in is shown there as 13.8 volts. One of the difficulties on the space station is that it's not actually what it says on the tin. It's not an international space station. It's actually two national space stations flying in close proximity and bolted together. They share the air and they share other bits, but one's built in imperial and one's built in metric, so there must be a bolt that's got imperial on one end. I don't know how it works quite, but the mains voltage in our language is 110 volts DC nominal on the American side and 28 volts DC nominal on the Russian side. The Columbus module, although it's a European module, it's actually in the American sector, so there are only 2 bits. And one of the things that are really hard to come by are devices to get this 28 volts down to something that most computers and stuff uses. And there's a thing called a blue brick, which is like a big computer power supply that you'll have, but the blue ones are the ones you want. They're 100-watt power or something. Anyway, so we've hijacked one of those, I believe, or at least borrowed it or found it. So and are using it. So I have to say that's a 20-watt PA. I don't know what power it's being driven to. So again, there's a question mark or an uncertainty in the actual RF output power. I believe the RF output power, by the time it gets through the filters and everything, is 10 watts. That's what the spec says. Unfortunately, because the funding level for this was quite low in terms of any ESA project, there is only one of these. They only built one model. So there's the flight model, which is also the proto-flight model, and that's the one in space. So there's no in space things, you normally do a test thing, a prototype, then you build an engineering model, and then you build a flight model, but they've just built this one. So there's not one on the ground to do any further evaluation, and they weren't keen that people played with it a lot before it went up because they didn't want it broken. Just some pictures of the SR devices boards and the PA. Some development drawings showing what the box was going to look like originally, and sorry, another picture of slightly out of sequence. Picture of the antenna that was taken at Kennedy before the launch, and as you can see, it was white, or they were white. It was in the wrong sequence. Okay, I'm talking a lot about link budgets. Sorry, I'm in your way. Certainly for space stuff, it is really quite important. I suppose it is for anything, really, but it seems to be important in the space world. We talk about budgets, power budgets, link budgets, and thermal budgets. So you've got the ham video exciter here, the PA there, there's the 10-watt output there. There's this feeder loss, which is shown there as 8 dB. Probably there's a gain of 8 dBi. Peter tells me that you can't get an 8 dBi patch, so it's a bit optimistic, etc. There's a path loss of 160.1 dB.
It looked like semi-rigid, didn't it, in the picture?
Yeah, it's yeah, but it's got to be space rated. It's got to be human flight rated. Blah blah blah. And we're passengers and we're not paying a commercial rate, so beggars can't be choosers. So what they've realised is that to actually run this for a school's contact, whereas there's one ground station on 2 meters can pick up the ISS from almost the horizon and hold the QSO the whole way round, whole way through the pass, really for TV it's going to be necessary to have a number of ground stations under the track of the ISS as it comes up and do a handover process. A bit like a networking system. We've got the signal, the next one takes it over. And this is where BATC comes in, because we've committed or allowed them to plan to use the web stream, our web stream system as part of their project, so that all these ground stations will submit their video as they get it to the web stream, and then the school will use the output of that on some self-selection process. I'm not quite sure how they're planning to do that. But so there's a whole load of the idea is that you'd have 3 or 4 for each of these contacts. Oh, crikey, sorry. Error, 42. Hit wrong button. Yeah. Oh, he's really gone interestingly with the sequence of these slides. Just a bit more detail of the box. 28-volt power supply from the cups. I'm not sure what that means. It's some Russian term, I think. And this box is designed to work with existing cameras on board. As you can imagine, there's all manner of TV cameras hanging around now in the space station. No doubt they vary from good, bad to indifferent, and they're ones that have been left over from other projects. Apparently we've been given access to 2, but they're battery powered. So one of the challenges is going to be to make sure the astronauts are aware that part of the process for the school's contacts with video is they've got to go and charge the battery for the cameras. We'll see how that works. And the 2 antennas are called 41 and 43. I'm not sure quite why that was. More details of it in situ. Here is a picture, an actual picture of the door into the Columbus module. And it's probably not at all clear, but the signal from the coax on the outside, the 2 antennas, comes into an external connector, which has obviously got to be airtight or whatever, and that presents here with a whole load of other connectors. It's quite a nightmare. And they're not they're not even terribly coaxial, so you've got another bit of loss opportunity there. And why can't they use N-type plugs like normal people? But they can't because it's space. So more uncertainty, I'm afraid. Oh yeah, picture of the cameras. Do any of us know those cameras at all? Are they good, bad, or indifferent? Okay, fine. Yes, I think one was left over from some high-definition filming on board. Again, another picture of the inside. It's very hard to see, but again, that's the doorway leading from the Columbus module out, and that's where the equipment's going to be located, somewhere there, I think. Doesn't show up very well here. That's actually a picture of the power supply taking the 120 volts, I think I said 110, I meant 120 volts, down to 28, and then there's the blue box that takes the 28 down to 12. Complicated. Well, okay, so the design drawing for the operator, for the transmitter, obviously in space you need big simple switches and things surrounding the switches, so you can't, not covers but protection bars, so that you can't knock the switch accidentally, and they're labelled in English, and there are alternative different things. They can switch between symbol rates. Low is 1.3, high is 2. There are 4 frequencies, only 2 of which are being talked about in public. So cover your ears on the stream. There are 2 that are below 2.4 gigs. Of the amateur satellite service is only between 2.4 and 2.45, right in the middle of the Wi-Fi band. And for whatever reasons, they've decided to put in 2 crystals that are below 2.4. Whether they'll be allowed to use those or not, time will tell. So that's what the box looks like, or it looks like in design. A bit more detail, the configuration, more power supplies, the camera down here, and the actual box that we're talking about, the ham video system. That's showing how it would be used with the audio antenna, sorry, the audio side, the voice side, with a D700 or a D710 in the Columbus module for 2-meter downlinks. Currently, they're using an old Ericsson handheld because the D700 up there's, I don't know, it appears not to do what it should be doing. Why one could conjecture that somebody's pushed the wrong button or whatever. So they're fairly complicated boxes, and they've been reprogrammed. And anyway, and there is the possibility of an S-band beacon there as well. So when that again is another project that we're working on that could be used for student experiments and could be transmitting a continuous beacon perhaps as an alternative to leaving the ham video system running, which may or may not end up happening. Just for those who don't sort of follow satellites very often, this is a screenshot of a tracking program, or actually a prediction program. It doesn't track, it predicts, but we tend to call them tracking programs. And that shows the footprint of the space station at any one time, and that will come up and just about go over the UK, or the coverage would just about go over the UK. I took that last night. So you can see it's only got a fairly small coverage area because it's really quite low. So antennas, let's come on to the ground side. The Italians have, I think, again got some funding for this, but there's 4 or 5 sets of kit that they're building up that look a bit like this. They, to me, well, sorry, not to me, what you need is a 1.2 meter dish. Doesn't have to be a very good one because it's only S-band. It doesn't have to be perfectly engineered. It could be mesh, or it could be a petal one or whatever. What you then need to do is obviously rotate it and elevate it. So here they're rotating it at the bottom of the mast, I think, the blue job there, and the elevation is on some sort of device there which raises the elevation, but you can also use the standard sort of Yaesu rotator and elevator. The one I use is the G550, which is more than man enough for the job. Fed or controlled through an LVB tracker, controlled through the tracking software or prediction software. So you can really, well, you should be able to set and forget that, because the orbital data for the ISS is very well known. You put that data into the tracking software, and as long as you've lined the antennas up and everything, it will track the space station as it goes overhead. So you can concentrate on doing other things, which is like trying to see whether you can get a picture. Now, lots of debate, lots of stuff still going on, lots of, I think, still uncertainties, and lots of research being done about which DVB-S boards or cards or set-top boxes will work at 1.3. I think the spec actually for DVB-S goes down to 2 megs. 1.5. Okay, so 2 megs then, any box should do it. At 1.3 there is certainly some uncertainty. But there's some work being done in America at the moment where the guy Bill Ress, who's done some evaluation and testing literally just this week. Point of this slide is that there's the Jean-Pierre, who was at Basingstoke last time for our last show, is running this website, Viva DATV, which is shown there in French, but there is an English page as well, and that's a centre for finding out what's going on, what's actually working, and he's also updating and improving his T-Tune software, which is really going to be, I think, really very useful to be able to see what's happening, as Noel was talking about yesterday. Noel or Peter was talking? Noel was talking about yesterday, being able to use it like an S-meter and stuff.
You've got the same problem though. You need multiple stations, and that doesn't change.
For schools to track, yes, yeah. So there's lots to be found on the web. That's a T-Tune picture that I grabbed from somebody's screen, but I think you saw that yesterday anyway, so something very similar. Yeah, he's continually updating it. There was a mod this week. So what I was hoping was, when Noel phoned me up or sent me an email and instructed me that I was going to be presenting at 11:05 on Sunday, what I was hoping that by this time was that the the kit is up there. The kit went up there on a Japanese freighter, I think in August. So long as they haven't lost it, oh sorry, so I hope they haven't mislaid it, because you can imagine people coming and going on something like Space Station, which has been there for years. Things do get mislaid if they're not sort of, I'm sure it doesn't really happen, but it's apocryphal stories. So anyway, it's a fairly big box, so assuming they haven't mislaid it, it should be put into operation and tested real soon now, literally next month sometime. It requires some astronaut involvement, and to get time for astronauts is like pulling hen's teeth, because it's, I don't know, £100,000 an hour is what they're costing the space authority, the space agency. So the space agencies are always very keen to limit as far as possible what they get their astronauts to do, because it costs a lot of money. Anyway, so sometime next month, and we haven't got any dates, we believe that the transmitter will be fixed and installed and powered up and left running for some time, like a day, so long as that, I know you saw there was a green light that said RFOK on the box. As long as that stays green, that will leave it running, with no camera attached. So what we could be looking for is a blank picture from space with the right...
Digital black.
A digital black, yes. The difficulty is there is no... They were not able to put in... We were not able to put in an SD card reader, which was our obviously idea, into the transmitter, so that it could just go through a series of stills and the next astronaut up could go and swap out the SD card for a new one. All these ideas which we tried to get were found to be not practical. So the first tests, we think, will be probably long duration, blank screens but with ID. I think they'll be at 1.3, but again, that might change. The second test, assuming that is satisfactory, second test, which will probably be a month or so later, will involve the astronauts, and it will involve a camera, so we will see pictures. But they will be short duration tests, again, as I say, because the astronauts' time is so valuable or so expensive. It will be over one pass over Europe sometime. The main ground station that the Italians are using is in Italy, obviously. It's a place called Matera, which is a radio telescope site, I think, as well, or satellite tracking site. So we can imagine that obviously the orbits of the ISS, the orbit doesn't change, but the Earth moves underneath, so that they'll be looking for an orbit where it's overhead a lot of Europe during the working week and during daytime, in all probability, because the ISS works on GMT. So you can look at the orbit predictions for the ISS and work out when the possible passes are that meet those sort of spec. So as I've said there, in summary, watch this space, because there's an awful lot of we don't know. Oh, ho. Oh, you think that's a ho, do you? Okay. So...
there's no limitation on the transmitter power then, even though it's doing digital black. There's no power shortage.
Oh, there's kilowatts of power on the space station. I think the power budget is not a problem. The thermal budget is. It gets too hot inside because there's so much energy. The solar, I believe it's 300. It must be 30 kilowatts, mustn't it? I was thinking overnight. We were talking about how much power the solar panels.
Last night, so
yeah, I know. Mr. Google will tell me later. But the solar panels are enormous, and the power they generate is an enormous amount of power. So, blank transmissions, complete DVB-S signal, black video, black, audio level nil. That's the test frequency we believe. 2395 is what we believe is the frequency that they'll be using for these initial tests. Symbol rate 1.3, FEC half, etc. And hopefully somewhere on some screen the word HAM TV will come up, will it? I'm not sure where would that appear. On your...
Well, be in the SI, won't it?
Mm.
The program name for it.
So that's what we want to see. So that's the sort of spacey end.
Can you just go back to the previous slide, because we didn't catch it on the stream.
For the stream, the previous slide again. Yep.
Yeah.
Happy, Mr. Director? So, if you are interested, what do you need? As I've said there, a 1 metre dish, maybe I'm being optimistic, maybe 1.2 is going to be necessary, but it's going to be something of that order. A right-hand circular dish, a right-hand circular, no, you get this right. If you've got a dish, here's a small one, in beautiful camouflage paint. I had problems not with my neighbours but with the planners, so it looks like a bit like a tree, doesn't it? Green. That you won't get this on the camera, I'm sure. But in here is a patch feed. It's a G3RUH dish coming from old AO40 days. Those of us who remember AO40 with love. So the patch feed is left-hand circular, because obviously it gets reflected by the dish, which makes it right-hand circular. The spacecraft, the space station, is transmitting right-hand circular. So the dish doesn't need to be solid like this. It can be mesh, but the ones that probably won't work very well are some that you see quite often used in the States, which are from some digital system they had, satellite system, which have got vertical rods, or horizontal rods if you have the aerial the other way, which are only really single polarization. So something like that, but a bit bigger. LMB, well, you either need the down converter right up by the aerial, or you have the low noise block right up by the aerial, and you have that one down in the shack. What you may need, of course, as well, is a decent filter in front of any of this. Again, that will depend on your location, how much Wi-Fi and other stuff there is around, and I'm sure to a degree how good your receiver is. So that's going to be a suck it and see as well. So commercial ones, yes, Kuhn, DB6NT. Other alternatives, I'm not quite sure. Does he? Okay.
Who does?
Okay. Yeah. Sam.
No, not Dan, but he does
Or he does the LMB, yeah. Yeah, okay.
Rob,
Is there an SSB
what are the
one?
down converters?
SSB is it?
Yeah, there may be.
Real L band.
Yeah. I mean, this is
That's it, yeah.
this is S band down to well, it says 2.3 in, 1.5 out. So S to L. An ASL rotator. Sorry.
There will be a 13.7 spear announced on RF design shortly as well. That's in development.
Okay.
Alternative there as well.
ASL rotator, which I've already mentioned. Satellite prediction software. There's a whole range of that available. Most of it's free. And an interface box to convert the information from the computer to the rotator. Say there's the LVB tracker is the one I use. A PC with a suitable DVB-S card, or a USB device, or a set-top box. The ones that a few months ago seemed to be very popular, or the ideal one, was either a Technotronics 3200, and that one belongs to Knoll, or the 1600 is also available. I believe these are now becoming very expensive. So, but they were about 30 quid.
We're not totally confident 1600 works.
Okay.
Graham says they.
Well, John Pierre says they work.
I am. He's the boss.
And not only do they work, but they work with his T-Tune, whatever it is, software. And then the vital bit there is the link to our web stream, so we can see what you're doing.
Hang on. So, are you saying you would like individuals to upload their video to stream their video if they receive it? Is that what
Yeah,
you're saying?
yeah.
So where would they put that?
That will depend on whether you, define a new bit, or sorry, we define a new bit for the of the web stream just for Ham TV. They can put it wherever they like.
Okay.
I think it's important to make the point that this isn't like I'm just going to tune in the ISS. There's so many things that have got to be right. You really have to preset for your receiver, and preferably have tested it somehow, and not have that as a variable when the thing's going over the top
Yeah.
of you.
Now here's a tricky question. We don't happen kids they used.
Yes, it's there.
Was it?
No trick at all.
Oh, very good.
What we did in the last time,
Standard SRs, yeah.
we put together an up convo which is pretending to be an ISS. So if somebody's going to seriously have a go at this, let one of us know, and we'll find a way for you
Well, then
to.
anybody with a Digilight or an SR system.
We'll load it. We'll either load
Yeah,
it
or
to your
the
house and you can set up your receiver. So
or the DTX1 will create that, won't it?
Yeah. Well, it would at L-band, yes.
Ah, it won't do it at S-band.
13 cents, you actually have to have one pretending to be an ISS, you see.
Yep. Okay.
Anyway, we've got one. Let us know if people want to.
Well, I've got a PC out. I've got a PC outside. If anybody would like to, during the lunch break, put one of these cards in and make it work.
Just coming back to this business about the streamer. So the Italian project, they've got 4 streams, ISS 1, 2, 3, and 4 on the streamer, and that's what the schools are going to be running. Yeah, that's the aim, is that would be what feeds the schools. What you're saying is, if anybody else wants to receive it, they can, and then if they wanted to put it up on their own personal stream,
they can, or they can presumably get ISS 6, 7, 8, 9, 10, whatever.
Yeah, we could do that.
And then the school can look at all of them and pick the best one.
But it wouldn't be integrated into the overall ARIS system, I suppose.
It could be. I mean, it will depend how well it all works out. It depends on how many ground stations, how many radio amateurs actually get keen enough to build the ground stations and to be willing to be at home or have their stations run remotely or whatever during the day. Because a lot of the school's contacts, of course, are, again, weekday and during the day. Bill Ress is, this guy over in California who's doing some research at the moment, like he is testing whatever DVB-S receivers he's got in his shack, and he's writing an article which will be in the next CQTV, I believe, but currently he's saying that those 3, whatever they are, have all been tested and decode at 1.3, and we were talking about sensitivity yesterday, and he says they're all at about neg 70 to decode, which I think corresponded with the numbers you were using yesterday.
Curious enough, the Technotrend was the least sensitive.
Oh, was it? I think I've read somewhere that the 3200 is less sensitive than the 1600. So that just shows that the 1600s are available. Another picture of the Tuition, and the last slide, really, the online resources. So why am I standing here telling you all about it? Because I'm really enthused by space and television, and this brings the two together, so I'm quite passionate about it. Unfortunately, at my location at home, my wife made me move home, and I'm surrounded by trees, and it's a nightmare, and I can only, the trees are 80 foot high and they're growing 2 feet a year. I really hope the gale comes tonight. I'm so looking. I know you guys don't want any wind. You can send it all in my direction. That's fine. So my location's pretty useless for trying to do this. Otherwise, I'd be doing it myself. I'm very happy to try and help anybody who wants to get involved with this or whatever. I've got some background experience, and I know quite a few of the really serious players. So it would be really good to have as many UK stations involved with this. It's going to be quite high profile with ESA and NASA and stuff. So the more we can do to show amateur radio in a good light, I think it'll be worthwhile. So thank you very much indeed.
Okay, thank you, Graham. The one thing you didn't talk about was susceptibility to Wi-Fi interference, of course. That's, if it is at 2400, that's going to be an issue. So rural locations, I guess, are best.
Farms are ideal, I think.
No, that's much more to do with the dish. You really want a dish that doesn't have.
Yeah, although if you're trying to pick it up at a horizon, presumably it would be,
yeah.
Another useful resource is heavensabove.com, where you can put in your location. Let me try this. Another useful internet resource is heavensabove.com, where you can put in your location. It'll tell you the visibility of the ISS.
Yep.
Of course, you can receive the current 2-metre transmissions on a rubber duck, on a walkie-talkie, no problem. So if you can actually see it, you can hear it as well at the same time. We've done this quite often at home.
Yeah.
The question is, what's the Doppler that you can expect on this?
Okay, I don't think that microphone's actually working, so I will repeat the question, or repeat the comment that heavensabove.com is a great website where you can stick in your location and it will tell you where lots of spacecraft are, particularly the ISS. So if you want to know when the ISS is next coming up, using that as an online source rather than loading any software yourself, heavensabove.com. The ISS is often on 2 meters, transmitting on 2 meters. You would need to go to the ISS fan club site. There's lots of places where you can go again to find out what the current activity is. But when it is transmitting, when it's doing schools contacts, it is enormously strong. Again, it's only sort of 400 or 500 miles when it's nearly overhead, and it's line of sight, and it is on 2 meters, so the path loss is very low. So you can hear it with a handheld with a really crummy rubber duck antenna without too much difficulty. Well, you could certainly when they were using the main station. The Ericsson is a bit lower power, but it's still pretty good. Question about Doppler. At S-band it's plus or minus 45, plus or minus 60 kilohertz.
It doesn't matter anyway. The AFC tracks it.
Yeah, which is much less than squirting freezer at. The rate of change is a bit higher, but so there has been tests done, and it is not it is not expected to be any problem.
Good. Thank you very much, Graham. Well, Terry. Sorry, say again.
We've currently put together a system on GB3KM to stream this out on repeater as well.
Oh, okay, good. Yeah.
So
GB3KM, you're building a ground station to track.
Yes, we've got the rotator.
Oh, that's fantastic news.
Controller, which is an old IF100.
Yep, that would work. Yep. Okay, so GB3KM team are building a ground station already.
And of course, Colin KLB is also trying to get something going down in Bournemouth.
Why don't you make the same request on the streamer? Because you want to know who else might.
Yeah, so obviously.
Yeah, and I mean, if there's anybody else listening,
yeah,
be good to know.
Yeah, we'll build up a list of active participants so that we can work together as a team. That would be really good. Yes, contact me if you like. The first